Welcome to my algebra class. We're on chapter 11, section 5. We're working with square roots in variable expressions. Variable expressions are perfect squares if the exponent is even. So x to the 6th power is a perfect square. If I took its square root, I would divide the exponent by 2, and it would be x to the 3rd power, and that would work because x to the 3rd times x to the 3rd would be x to the 6th. So the following, the square root of this radical expression, variable expression, would be 6x to the 7th. This would be 16y to the 2nd, dividing the exponent by 2. So it would be 6x to the 4th. This is m squared minus 6m plus 9. It's a perfect square trinomial, which is m minus 3 quantity squared. And perfect squares, the middle is twice the product of their square roots. So the square root of that would be 1m minus 3. And the last one, the perfect squares are within the number and the variable part. So this is 9 times 2. And a cubed is a to the 2nd times a. So I can take out the perfect squares. The square root of 9 is 3. And the square root of a squared is a. And what's left is radical 2a. You're going to be solving equations. One method was factoring that we learned before. So if I brought that over, I have a binomial, and the ends are perfect squares. That would be 3x minus 8 and 3x plus 8 equals 0. Now if I use square roots, this is another way of solving this. Get the square by itself, the variable squared by itself, so I divide both sides by 9. So I get x squared equals 64/9. And going back to this one, the solution to this would be 8/3 and negative 8/3. And here I take the square root of both sides. So x equals plus or minus the square root of 64/9, which is 8/3. Because you could have one positive 8/3 would make 64/9, and negative 8/3 would make 64/9. So both of them work, and we're going to be using this method in our problems. So we're on 526, and we're doing written 1 through 50. Problem number 2. They want us to simplify. It's the square root of 100z squared, so we got to take out any perfect squares. The square root of 100 is 10. The square root of z squared, divide the exponent by 2, is z. Number 4, we have the square root of 32b to the 4th. So 32, the largest perfect square, and there's 16 times 2b to the 4th. So we can take out the square root of 16, which is 4. The square root of b squared, which is b. And we have radical 2 left. Problem number 6, we have negative radical 64x to the 2nd power. Square root of 64 is 8, so it's negative 8. The square root of x squared, divide the 2 by 2, we get x. Problem number 8, negative square root of 16d to the 8th. So it'd be negative, the square root of 16 is 4, and the square root of d to the 8th is d to the 4th. Remember, divide the exponent by 2. Number 10, we have the square root of 49, a squared, b squared. The square root of 49 is 7, the square root of a squared is a, and the square root of b squared is b. Number 12, the square root of 80, n to the 6th. The largest perfect square in 80 is 16. That's 16 times 5, n to the 6th. So we can take out the square root of 16, which is 4. The square root of n to the 6th, which is n to the 3rd, radical 5. Problem 14, plus or minus the square root of 56, r to the 6, s to the 4th. So the perfect square in 56 is 4. So 4 times 14, r to the s, 6 rather, s to the 4th. The square root of 4 is 2, so we have plus or minus 2. Square root of r to the s is r to the 3rd. And the square root of s squared is, s to the 4th is s squared. And then radical 14 is left. Problem 16, the negative square root of 400, a to the 6th, b to the 4th. 400 is a perfect square, it's 20, so it's negative 20. Divide 6 by 2, we get a to the 3rd. And 4 by 2, we get b to the 2nd. Number 18, plus or minus the square root of 256 over 400, s to the 12th. The square root of 256, if we're not sure, we can double check here. Should be 16. Let's see. Okay. 256 is 16. So plus or minus 16, square root of 400 is 20. And 12 divided by 2, the square root of s to the 12th is s to the 6th. Now that can be simplified further. 4 goes into 16, 4, and into 25. So it's 4 over 5 s to the 6th, plus or minus. Problem number 20, the square root of 45m cubed n squared over 5m n to the 4th. I'm going to do a little division here. 5 goes into 45, 9. M and m to the 3rd goes to m to the 2nd. And n squared over n to the 4th, I have n to the 2nd left. So the square root of 9 is 3. The square root of m squared is m. And the square root of n squared is n. 22. The square root of 324 r to the 50th over 49. 324 is, the square root of that is 18. R to the 50th even divided by 2, that's r to the 25th, and 49 is 7. And that's all we can do with that one. '24, we have the square root of 1.96, a to the 6th. 196 is a perfect square. 1.96 would be 1.4. And k to the 6th, that's even, so divided by 3, it's k to the 3rd. Divide by 2. 26, we have the square root of m squared minus 12m plus 36. The ends are perfect squares. It looks like a perfect square trinomial. So we'll try factoring. The square root of m is squared is m. The square root of 36 is 6. And 12 is twice the 6. Put a minus sign. So the square root of that would be one of them. So 1 factor n minus 6. They'll have to excuse the storm. 28, we're going to be solving equations. We have n squared equals 64. The n squared is by itself. So we're going to take the square root of both sides, so n equals plus or minus the square root of 8. Both numbers work. Remember, the exponent's 2, so we should have 2 answers possible. Number 30, we have d squared minus 49 equals 0. Get the square term by itself. D squared equals 49. Add 49 to both sides. Take the square root of both sides, so d equals plus or minus 7. 32. We have 0 equals m squared minus 81. So 81 equals m squared, adding the 81. Take the square root of both sides, so it'd be plus or minus 9 equals m. (34) 50b squared minus 450 equals 0. First move the 450 minus 450 by adding it to both sides, so it equals 450. Then divide by 50, and we get b squared equals 9. Take the square root of both sides, and b equals plus or minus 3. (36) we have 9c squared minus 64 equals 0. Add the 64 to both sides. 9c squared equals 64. Divide by 9. So we have c squared by itself equals 64 ninths. Take the square root of both sides. So c equals plus or minus square root of 84 is 8 and 9 is 3. 38, 0 equals 80 p squared minus 125. Add the 125 to both sides. So now we have 125 equals 80 p squared. Divide by 80. And we get p squared equals 5 goes into 125 25 times, and 5 goes into 80 16. So now take the square root of both sides, and we get plus or minus 5/4 equals p. For the last set of problems, find both roots of each equation to the nearest tenth. So number 40, a squared equals 154. We're going to take the square root of both sides, so a equals, and 154 is not a perfect square. And they said take it to the nearest tenth, so it's plus or minus 12.4. Number 42, we have 0.29 equals k squared. Take the square roots of both sides. So 0.29, the square root of it is 0.53. So our answer is plus or minus 0.5 to the nearest tenth equals k. 44, w squared minus 204 equals 0. W squared equals 204. Add 204 to both sides. Take the square root, and we get to the nearest 10, 14.3. So it's plus, w will equal plus or minus 14.3. (46) we have n squared minus 13.08 equals 0. Add 13.08 to both sides. Take the square root. To the nearest tenth, it's 3.6. So n equals plus or minus 3.6. 48, we have 7z squared equals 133. Divide both sides by 7. So we get z squared equals 19. Square root of 19 to the nearest tenth is 4.4. So z equals plus or minus 4.4. And the last problem, 0 equals 6n squared minus 0.42. Add 0.42 to both sides. Divide by 6. We get 0.07 equals n squared. Take the square roots of both sides, and we get to the nearest tenth 0.3. So our answer is plus or minus 0.3 equals n. And leave because the storm was getting to be too much.